Hi, my name is Henry Sang. I'm the Director of Business Development at LAON People America. Today I'm here to talk to you about our automobile surface testing. It's a very challenging type of problem for us. You may know us as the people who have brought many other types of solutions. In fact, at the show today, Luke Fabian is showing our AI traffic solution demo, and we have another over-the-shoulder session on our AI tools, the Navi tools. But we work everywhere from hardware, as you can see on the left, from chips all the way to camera assemblies, all the way through software to full solutions. Now, the problem with automobiles is you have a very large, very highly reflective surfaces, non-planar, and you have a lot of different types of defects. Let's just take a look at those defects so you can see what the problems that you're up against. Here are bubbles. These can be under the paint. They are generally pretty small for something like a car, but they're hard to see. Same way with chill flows. This is where there's a little paint, and before it's actually set, gravity has caused it to move, and it forms these little bumps. Another problem you have is with dust. In a factory, there's a lot of dust, and sometimes there's electrostatic attraction. It gets on there, and then the paint goes over it. Now, these types of three defects are extremely hard to see. You have to usually have the light at just the right angle before you can actually see one of these things. Other types of problems come from handling. So we get scratches, and this can happen because the worker hits it or a piece of machinery or something happens in the factory, and you end up with something. This one's at a joint, but a lot of times it's actually along the paint job. Oftentimes at one of the crests where you have a detail that's sticking up a little higher. Sometimes you actually just get bad coatings. Now this is the type of thing that you can actually monitor with traditional machine vision. But let me show you what we had to do for taking a whole car through a system. So we created a light tunnel, and the light tunnel has both a white field as well as the structured light area. You see those bars, and it has a conveyor belt, and we can move a vehicle at a very steady pace through that tunnel, and you can see their cameras top and on the sides, so we can record these patterns that are coming by as we go through it. Now, in that tunnel, we do have probably, I don't know, probably 20 or 30 cameras, and these are special cameras. But what the structured light part is the more interesting thing, the novelty. And there we have these bar patterns, and they're not static, and we project them onto the surface, and the camera can actually see these patterns. And you can see the thing on the left, that's called a moire pattern. And you can tell when the car is going through, it's got to not only just find a static moire pattern, but it's actually going to go on the bumps and the ridges and things like this. So here's an image of a hood of a car with the various different defects that have been magnified, and you can see a moire pattern. Now sometimes you have other types of problems, such as a very shallow dent. It's very hard to see, and so what we actually did was we used the light field that we have and did a structured light 3D assignment on it. And so it's like an ellipsometry process where you can actually measure the depth of the surface relative to the fixed light source and the fixed detector. But sometimes we're finding new types of problems, and so we also use an unsupervised learning technique where we can take a look at a known good car and panels and everything on that, and then we take a look at the sample car coming by, and we try to spot new types of defects. And this gives us an opportunity to actually learn what's going on and to adapt the system as we get more experience with it. Now, to do this, we needed a lot of cameras, as I mentioned, but we also needed very special ones. And so we built our own cameras. These are very high frame rate, as well as having large bit depth, and I think this is like a 12 megapixel camera. So we have a number of these in that tunnel. Yeah, we do a lot of the work in our shop. I can't show you the footage from the install that's happening at a car company now because that's proprietary, but you can see that we take samples either of a small portion of a car, or we take actually a full car, but you notice we don't have a conveyor line here. We actually have to move the light source or the lines. And you can see what it looks like when we move the pattern. This one's we're moving the lines past the car, and we're recording that. You can see that recording actually on the screen to the side. So here's what a full car scan looks like. So on a typical side of the car, you're going to have multiple cameras. This would be like the top of the panel. And you can see we've shown the various different defects, and you can see the scratches that are becoming quite evident in the blue. On the lower panel, you can see we start with some dents that are right around the wheel well. And as it scans back, you can see that we will start to pick up other patterns that the system has analyzed. So we don't just use the full car thing setup. A lot of times we use a benchtop setup where we can actually calibrate and learn, train our AI systems on various different types of patterns. And so you see this. Now this is the very same type of system that you might use for checking your inbound QC on parts that you get from someone else. So I can imagine this being on a variety of other types of manufacturing line environments or on conveyor lines. So I'd like to actually now switch over to Q&A. So could you take me back to full person view?